this video, we will be discussing about indicators.
Let us first know what are indicators. Indicators are the weak organic compounds which change their color in accordance with the pH of the solution. They dissociate slightly in the solution, producing ions and undissociated molecules. The color of the ions produced is dependent on the hydrogen ion concentration or the pH of the solution. But what is this pH scale? pH is the measure of how acidic or basic a solution is. The range goes from 0 to 14, with 7 being neutral. pH of less than 7 indicates acidity, whereas a pH of greater than 7 indicates basicity. pH is really a measure of the relative amount of free hydrogen and hydroxyl ions in the solution. The solution that has more free hydrogen ions is acidic, whereas the one that has more free hydroxyl ions is basic. pH is defined as the negative logarithm to the base 10 of the hydrogen ion concentration expressed in moles per liter. Now, let's know some of the types of indicators. Firstly, the litmus solution. It changes red in acidic solution, blue in alkaline solution, and purple in neutral solutions. Methyl orange solution. It changes red in acidic solution and remains yellow in neutral or alkaline solutions. Phenolphthalein solution. It is orange in solution of pH from 0 to 3 that is highly acidic, colorless in pH of 4 to 7 that is slightly acidic or neutral, pink in solutions of pH 8 to 10 that is slightly basic or little basic, and again colorless in solutions of pH 11 to 14 which has high basic character.
We have acids and bases all around us, and today we will be identifying them,
for which we need to make our indicator first. The materials that will be required for our indicator is a red cabbage, water, and a big bowl. Why red cabbage? Red cabbage contains the pigment anthocyanin that gives it that reddish or purple color.
Anthocyanins are the water-soluble vacuolar pigments that change their color according to the pH of the solution, that is, to pink, purple, blue, or black. Anthocyanins may be used as pH indicators because their color changes with the change in the pH of the solution. They are red or pink in acidic solution having pH below 7, and they are purple in solutions having pH equal to 7, that is the neutral solutions, and they become greenish or yellow in color when the pH is above 7, that is in alkaline solutions.
Here I have the small pieces of my red cabbage. On the other hand, my water is started to heat. Now when the water starts to boil, I add the small pieces of the cabbage into it.
Now we see our cabbage has lost all its anthocyanin content and it's mostly white.
After straining, we will allow our indicator to cool for some time. Our indicator is now ready.
Now let's see the change of our indicator in two solutions. Here I have an aqueous solution of acetic acid, that is simply white vinegar, and here I have an aqueous solution of sodium bicarbonate, that is simply baking powder. Now I will add my indicator into it to observe the color change. We can see our acid has turned dark pink or red in color, whereas our base into green. So we know our indicator turns a base into green and an acid into red. Now I have picked up some household products on which I will be doing the same experiment. Here I have the household products: washing powder, tomato ketchup, soda, that is the carbonated drinks, shampoo, lemon juice, and toilet cleaner. Before adding our indicator into it, I would need to make an aqueous solution of it. Here I have all my aqueous solutions. Now I will be adding my indicator into each one to check its acidic or basic property. Here are the outcomes. The washing soda has turned green, proving it to be a base. Our ketchup has turned into a dark pinkish color, proving it to be an acid. Our soda, a carbonated drink containing carbonic acid, it also turned pink. Our shampoo has turned into a dark green color, proving it to be a base. Lemon juice, the citric acid, yes, it's also pink. Toilet cleaner, it had a beautiful blue color before adding our indicator, and now it's dark pink in color.